Well, good evening, everyone. Hopefully, I'm live. Um, I've just had a race back home from what I've been doing all day, in a bit of a panic, just trying to get myself sorted out. So, not quite got all my lights turned on and everything. But anyway, here we go. I'm here. Lovely to have you with me. Um, I was just going to mess around with some more electronics today. Last time I had a stream, I was trying to get a. Hold on, let me change the scene. Last time I was. Here we go. So last time I was messing around with this. I can't remember what part this is called. Anyway, it's a motor driver, and I used it to drive this, which is a Tortoise point motor. So that's good. But today the problem with these is they're quite big. It's got this great big heat sink. It can push. It can drive like 3 amps, I think. I don't need 3 amps. Actually, I don't know what I need for this. Perhaps I can find out in a moment. But we'll talk about that. But what I thought is I'd try using this instead, which is just like a smaller version, basically. It's slightly different in several ways, but if I can use this to drive, let me show you that. In the middle of the screen, there's the middle. Okay. If I can drive that, then that will drive two Tortoise point motors, and I can get several of these lined attached to an Arduino and make my own point motor driver thing. So that'd be good. Right, let me just get a little bit more organised. What do I want to do? Yeah, let me put that over there. Right. Now, there's one thing I want to do, and that's just turn the light on. My desk is a bit of a mess. Oh, the other thing, I told you, I just came racing in from my busy day, and so I've got to grab myself some food. So for supper, I'm having porridge with banana in it. It's just porridge with honey and banana. It's very good. Right. Try and turn some lights on. Maybe that works a bit. Whoa. It's a bit too much, I think. Yeah. All right, that'll do. Right. So here I've got a breadboard. Now, this, I think I didn't have a good power supply for it, but this can drive up to 40 volts, I think. So that was fine. So I just grabbed some power supply that I had. This one, I think. There we go. They said it was a 12-volt power supply. But actually, it turned out this was putting out 16 volts. Let's have a look at that. And that was a bit boring because it meant I didn't have 12 volts. So what I wanted to do, just plug this in for a moment. What I wanted to do was to get myself a proper 12-volt supply. I said I've got one on the layout. I could use that as like a computer power supply, but that's on the layout, and I do my computer's over here doing the streaming. So I will come on to my cunning plan to get 12 volts in a moment. Key feature of this thing, by the way, that I want to use, that can't drive 12 volts, it can only drive 10.8. So that's a limiting factor. If that could drive 12, it'd be an amazing thing. Exactly what I want. Right, I've set my multimeter up here, volts DC. So let's just see what this power supply is giving us. There you go. It says 16.5. It's pretty steady. It's a steady 16.5, not a steady 12, which is what it says on the label, which is a bit annoying. So to get around this problem, oh, by the way, I'm eating porridge, I'm drinking coffee. I definitely need. Now, in order to get round that problem of not having 12 volts, somewhere I've got a little thing that I bought. No. Those. Isn't it fun having loads of bits of electronics knocking about? Here we go. I think it's this. I got from Halage. Now I got these off Amazon. I think I got 5 in the packet for about 6 quid, 7 quid, something like that. Not much. Anyway, it's just a little component. I've already opened one, so let me show you. Find one that I've already opened. Here we go. Oh, I've already opened 2 actually. Right. Oh no, I haven't opened that. Wait. There's another one somewhere. Anyway, we'll have a look. So I've already opened this. There's the one. There's the one. Right, I've already opened this. And I've fiddled around with it a bit already. Perhaps you can see it's basically got connectors on the 4 corners, and they're labelled in positive, in negative, and out positive, out negative. So I've just put a pin on the input either side, and I've soldered on some wires on the output. Just put tube-on connector there so I can plug it into my breadboard. In fact, I've got one here that I used earlier. I'll come on to that. So, and here I've just got a bit of wire with tube-on connectors in on it, so I can connect that to my new magic thing. Okay. That's good. And then I can take my, so this is my 16 volt supply. And now I can plug this into the breadboard instead. And I can measure the voltage coming out. So what this is a buck converter. And so that will drop voltage quite efficiently. It doesn't drop it by just burning it off. And then, oh dear, well, that's on fire, so that's no good. Not quite sure why that's on fire. That smells like a capacitor on fire. Oh wow, look at that. There's a that is definitely letting the magic smoke out. I smelt it before I saw it. Why has that happened? Wow, and look, that connector's come off the edge. Don't know what happened there. Oh, I do. I know what happened there. Right, well, there's a little lesson. So, oh dear. If any of you come across a YouTube channel called Electro Boom, he literally does this. He blows stuff up. It's really funny. But I didn't expect being electro boom myself. Right. So what's happened is it's got hot. It's burned out this chip here, which is that's the main chip, the buck converter. So this is obviously broken now. So that's a shame. But the reason that happened is because I plugged this in the wrong way around. So this is my 16-volt supply. Got my black wire and I plugged that into the red wire because I wasn't paying attention and I was talking and I was going too quick. So that is my fault. Right, that goes in the bin. I think we're going to have to try again. Which is what happens when you sort of come in a rush. Right, that goes in the bin. Well, luckily I've got another one somewhere. Here we go. Here's the other one I got. Same thing. So I've got 5 of these. Well, I've got 4 of them now. So what we've learned is that if you plug the voltage in the wrong way around, it blows it up. So that's a shame. Right. Here I got my 16-volt supply. Red goes to red, goes to in positive. Black goes to in negative. Right, now this is looking better. So a light's come on, and we can test the voltage. So you see the meter, you can, can't you? And that's saying exactly 10 volts. Now it's saying 10 volts because I've used this before and I've already had a little fiddle with it. But the key thing is that there's a little potentiometer on the top here, and by twisting this I can adjust, you can see that well, I can adjust the voltage. So if I just use some crocodile clips to connect, let's have a look. So I use some crocodile clips there and then just hook onto my meter leads. And that should, there we go. So that's now displaying 9.6. So if I turn the potentiometer, I can use that to set the voltage. It'll go right down. There we go, 5, all the way down to, I think it goes down to about 1.2. That is the lowest. Turned it up, so 3.3 is a common voltage. Let's see if we can get that. That's used for some logic stuff. To just get a little tweak on it. 5.4. Sorry, 3.4. 3.3 almost. There we go, 3.32. So that's good. Well, we could get up to 5. Let's see how high it can go. No, I turned it the wrong way. So it's taken multiple turns this. So perhaps this is what they call a 10 turn pot. There goes 7, we're up to 8, 9, 10, 11. I could stop at 12. So there we go. So that would give me my perfect 12 volt supply. So that's good. We should be able to keep going up. We've got 16 volts going in. 16 and a half. And this will give us a maximum of 14.6. So because it's a buck converter, you can't have less voltage. It can't give you more voltage than you put in. If you want that, you need a boost converter, which is a different thing. Anyway, let's set it to 12 first. So there's 12. And we have a little think about what we were doing last time I was on. We were using this to drive this. Which is the Tortoise point motor. So we have 5 volts on the top bus. I haven't got 5 volts yet, but we'll come back to that. Put the ground in, bottom, and this bottom bus is we're powering to 12 volts. Now, I've had a little fiddle with this already, and I've put a dew point connector on the end of my Tortoise point motor. But this doesn't have dew point connector, so perhaps I just need to make up a wire to connect the dew point connector to this thing. So let me find a way of doing that. So we got blue and yellow wire. So let's see if we can keep that convention. Blue and some yellow wire. Yellow wire. And blue wire. Okay. So we'll make up a little harness using this. Okay. No one's very chatty in the chat today. That's my meter. So one of the things going on is my boiler's broken, and that's the reason that I'm having to sit here with an electric fan heater going. That's really noisy. That may be why no one can hear what I'm saying. So in a minute I'll go and turn it off, see if that helps. But it's so cold in the house. Right, so we've got some bits of wire. So we'll strip the ends. So for dew point connection, you just take a tiny, maybe 2 millimeters off the end. Tiny bit, tiny bit. There we go. And another one on the yellow. And then I need my 2-point connector clamps. That's good. And I need male connectors, don't I? Get a couple of male connectors. Almost run out of female ones of these. I need to get some more. Something I discovered about this sort of stuff is you need to keep on top of your inventories of stock. So when you see you're running out of something, you sort of add it to a list. You've got to find a way of ordering what you need without paying just as much with postage every time. So you sort of bulk up and order stuff. Right. So I take the thing, I put it in the clamp, hold it, then I shove the wire in one end until I can just see it emerge on the other, and then I clamp it up. There we go. I used to be terrible at this. I spent ages and ages learning, and then once you've got a routine, once you've figured it out, it's really easy. That's that one too. Just go and turn this heater off. Don't know if you can hear it or not. Right, that's about it. I'm not sure if I've got a 2x1. Well, I think I can see one. These sort of housings for these dew point connectors. That's 3x3. I want double 2. That's what I want. These were all sort of nicely laid out, and then dropped it or whatever, and they all get mixed up. There's a 2. See, I'm running out of 2s as well. I mean, that's sort of obvious that you're going to need more 2s than anything else. Okay. So if I stick this in here, and then I can strip the other ends, clamp them. Now, for some reason, this is flashing. Not sure what that means. I'm just going to unplug this. We'll come back to this. All right. So I don't really seem to be doing much electronics. I just seem to be doing a lot of wiring. With the male ones, you can feed it through and then grab the pin with pliers and pull it all the way in. You can't do that with the female ones. Obviously, you have to push it in. So that means I can plug that in there. So if I want a bare wires on the end of my Tortoise, I can have them. But if I want to have a plug, I can have that as well. So I'll just strip these wires off. Right. So what this means is that I can screw this into here. I don't think it matters which way around it goes. Obviously, if you do this the other way around, then your point motor will go the other opposite way. There we go. Right, so that's good. So I can attach my point motor. Okay. So what was going on with this power supply? So I think this should be okay. Just got to make sure I don't plug it in the wrong way around or I'll blow it up again. So black to the minus, red to the positive. And then it sort of flashes a bit. I wonder if perhaps this pin's not, one of these things isn't soldered in right. That seems alright. Why is this thing a bit unhappy then? Right. If I plug it in again, so that's giving me a few millivolts, which isn't really what I wanted. There goes 0, it says. That's because it came unplugged. 15 millivolts. I did have this set up for 12 volts, so I haven't blown it up again. Don't feel so hot. It does seem to be. I don't know what's going on with this. I've already blown one up today. I don't really want to blow another one up. Say, I'm not massively impressed at the moment, and this is getting sort of a little bit. There we go. Oh, okay. So I had that turned like that, so it's obviously low voltage, and as I turn it up, it's got more. Let's see what voltage it's actually putting out. So that says 4.8. If you turn it right down, the light goes out. But if you turn it up, you can just see just here, the light comes back on again. And that makes sense. If there's not enough voltage to drive the LED, then that's no good. Now I did have it on 12 volts, didn't I? So let's get it back on 12 volts. There we go. 12 will do. there you go. So that's my 12-volt supply. We're all happy with that. Good. 12-volt supply goes into the power here. The load's connected, which is this Tortoise point motor. So that's good. Let's turn this around a bit. Okay. So what else did we have? Well, we need to have a 5-volt supply on the top rail, because we're supposed to be providing 5 volts, and for that I've got another transformer, and I think this was providing 12 volts, sorry, 5 volts. So I think so I can plug that in, and let's have a look. Red to the top. So we plug that in. So lights come on this driver circuit. So that's obviously getting power now. And that all means that I should be able to control this driver circuit. So this is what I was doing last week. So if I just plug this in here. Now the difference between this and what I was doing last week is that I'm driving it with 12 volts, not 16.5. Let's see what happens. There we go. And that moves across. That's very nice. And then it moves back. Okay. But we've not done anything we haven't done yet now. So what I'm doing is I'm using the 5-volt logic signal that's not drawing much current in order to run the point motor. Now, I did get a package. It was on my doorstep this evening when I got home. And I know what should be in there. There should be a quite a sensitive ammeter measuring current. So what I'd like to do is to see what is the current draw on the Tortoise point motor when it's turning over, and also when it's stalled. Of course, they say it draws very little current when it's stalled, which is great. But I'd like to know how much current. Here we got a package from Amazon. That is a little box from Amazon. The bin. So I'm assuming this is what I think it is. So what it'd be interesting to do is to see how much current is drawn by the Tortoise, and then compare that how much current is drawn by the logic signal. And I think the answer should be, on the logic signal, almost none. This. Look at that. Milliamps, it says, goes up to 100. So we'll see how many milliamps it draws. There's some nuts and bolts here. Not quite sure how the nuts and bolts are supposed to come on. Put it. Can you see that? No, you can't. Where can you see? You can see there. So let me put some wires on this, and then we can use those to measure what's going on. This is all quite fun. A whole bunch of washers and stuff. Different sizes. I'll put 2 washers, and I think there's a spring washer and a nut. Oh dear. Why can I not do this? There we go. Nut. So what I'm trying to do is to find a way of building my own point motor drivers. So if I can drive it off a logic input, 5-volt logic input, then I can use an Arduino to generate that 5-volt logic input, and I can and then I can use either the Arduino to either decode DCC or just take instructions straight off the LocoNet in order to drive it that way. So, but I want to find a way of doing it that's cheap. So it's cheaper than buying all these bits of kit that cost lots of money and then they stop being made and stuff. So I'd rather have control of my own things. Right, so what we're looking to do is to measure the current. Now, in order to measure the current on this, I need to put this sort of somewhere in between. Let me get a bit of yellow wire. There's my old blue wire up there. There we go. If I strip this at either end, you can have one little wire going to the ammeter and the other into the board. I think what I'm going to do is just plug the power sources on this. There we go. So I don't blow anything else up. They're quite good at blowing stuff up. Oh dear, I can't believe I had my first sort of electric boom moment. Very good, very good, very good YouTube channel. I know he's sort of pretending to blow stuff up all the time, but I think he probably knows what he's doing. He's doing it on purpose. Right. Shove that in there. Mess that one up. Why is this not happening? Because I need a longer bit of wire, perhaps. I need a longer conductor. and then I can send this to the ammeter on one end and do the same on the other in a minute. I think this could be done better, but alright, hopefully as long as it's connected, I'll be able to measure it. So if I strip the other end, okay. Right, so that's not great, but I think that'll do for now. Keys, can you see it? Just put this up here. Yeah, that's the old. Right, so I think we're doing all right now. So we've got a voltmeter measuring the input voltage. We got an ammeter measuring the how much current's being drawn. And there's only one problem, which is I've lost this connection here. Let me redo this. Yellow wires come out the motor driver. So how hard can it be? I often give myself some things to do that aren't easy. Maybe I just make a meal of it. Right. There we go. So I hope you can see that. So the Tortoise point motor. Current goes through an ammeter into the motor driver. The motor driver is getting 12 volts from this little 12 volt buck converter, and we can check that's what we're getting 12 volts on here. And then the logic is being provided by 5 volt transformer. Right, let's plug it in, see what happens. Okay, so 12 volt supply is on. The motor driver logic's not on, and that's because it's 5 volt connections come out. So let me just plug that back in. There we go. So now we've got a wire there. So if I now provide some logic, and we can see there the ammeter was registering something. Do that again. Wow, look at that. So it's drawing 18 milliamps when it stalls. However, it draws a lot less when it doesn't stall. So watch this. I don't know if you can see this. I have to find a way. I might adjust the camera in a minute. So when it actually runs, it's drawing about 5 milliamps, and then when it stalls, it's drawing about 15 milliamps. So they say what's great about these Tortoise point motors is that they don't draw much current, but actually they do, particularly if you've got lots of them that aren't doing anything. I'm not sure I like that, to be honest. Let me just try and put the camera down a bit so you can see a bit easier. Oh, right. Can you see that? Hopefully you can. Right, let me try that again. So I'll put the motor back, so it's going to go in reverse, so that there we go. Now, if I drive it, it's fine until it stalls, and then it pops up. Right. Okay. So this is what happens when you drive it with 12 volts. Let's just see how long it takes to go if the driving voltage is 12 volts. ABC1, ABC2, ABC, so it's about 3 seconds. ABC1, ABC2, ABC3. Okay. Now, what I want to do is to use this as the driving circuit instead. They don't come like this. I've soldered some pin headers on, some header pins on, so I can plug stuff into it. Yeah, it's not sort of what I hoped for. Oh, sorry, it's small, much smaller than this. So I'd like to be able to use this one. However, the problem with this is it only takes 10.8 volts, I think. So what I'm going to do is adjust this buck converter down to 10.5 volts. What I'll do, I'll put you up again so you can see a little bit more of the desk. There you go. Right, let me change this to 10 volts. So it can take 10.8 apparently, but we'll turn it down to 10. There you go. 10.1. So this is the driving voltage. The logic circuit should still be at 5 volts. So let's try it again. And I'd imagine it'll go a bit slower. It still goes. ABC1, ABC2, ABC3. To be honest, it doesn't really make any difference. So that's good. So I can drive the Tortoise point motor at 10 volts, and this thing should be able to handle 10 volts. So let me turn it all off and rewire everything to use this instead. Just have a look at it. So I've soldered on some pins. It's got INT1, INT2, and I think you can provide a sort of pulse width modulation signal to that, one way round or the other, to go forwards and backwards. But I think if I just provide a constant 5 volts and 0, that'll drive it. I've got the Tortoise point motor circuit or the motor out, so I'll just plug the point motor straight into that, and then here is the power supply. What I've got, or what I can do, I've made up. Okay, if I take, so this is my 10 volt rail along the bottom. So I'll take that and plug it in here. What's the positive at the top? Yeah, I don't want to keep blowing things up by attaching power the wrong way around. Now I can remove this. There you go. So actually this all looks a bit simpler. It's got less stuff to plug into it, a lot less header pins and so on, but it does, I don't need any of the extra stuff the other one's got. I certainly don't need it to drive 3 amps. It looks like I only really need 15 milliamps, 20 milliamps at the most. Anyway, let me plug this back in and see if I can get this to work. Okay, well, we got power. The power's giving us 10 volts. So let's connect to signal circuit. Oh, look at that, it works. So it goes from one way to the other. Whoa, I just heard something go. Oh, what's going on? For some reason this has dropped to 2 volts. Let me unplug that. Is this getting hot? Why is this dropped to 2 volts? Let me unplug the... That's on 10 volts. Okay. Let me plug that in again. And it's dropped to 3. Why is that? Is this thing blown up? So for some reason, oh dear, don't know what's going on. So this still works. I can still adjust the voltage on it. So if I get it back to 10 volts. But when I plug this driver thing into it, it's not happy. Let me try again without the load. And it's done it again. So this has started smoking and getting hot. So I think somehow I've managed to blow this up now. That's not a good sign. Let me just leave it plugged in and see what happens. There we go. And the smoke's coming out. You see that? So I've blown it up. Right, that's the second bit of electronics I've blown up today. I'm not having much luck. Right. go in the bin as well. Quite a big sort of bin pile today. Right. I think what I'm going to do then, get these power supplies out. I'm going to get the soldering iron going. I'll solder up another one and then give that a go. And if I can't get that to work, I think we're going to be calling it a day. I'm going to go home wondering what's going on with these things. Right, soldering iron getting hot. So here's my pack of goodies. I think these are these drivers. Something happened there. There was a little spark or something. I wonder what to stream back, see if I can see what I did wrong. Feels like I sort of shorted something out. But it was obviously, something happened and then it was damaged. It did work, then it didn't work. Right, get the bin. Now let's get some connectors. Need these in groups of 2. You can get a whole load and you can just snap off. What you do is you get needle nose pliers and connect along as many as you want, and then you just break it off. So that's 2. There's another 2. There's another 2. Right. So if I go for motor A, something like that. I need a way of sort of holding that in while I solder it. So just balance it. Right, I've got my soldering, I've got my solder, I've got my soldering iron. It should be hot. It's not because I've not plugged it in. Wait for that to heat up. Oh dear. Actually, I'm really disappointed that thing blew up. I wasn't expecting that at all. I don't know why that happened. Because I'm thinking those little circuits might be the solution to my problem. The only problem is if I use them, I've got to work out where do I get a 10-volt supply from. And that's fine. You can say use one of those buck converters, but that then adds to the cost of the solution. The whole point was to like make it cheaper. This isn't well soldered. The other foot. Straight, but it's on. Try the next one. One more header. So the spacing on these holes is pretty non-standard, which isn't a good thing. There we go. It's not my best work, but it will be electrically connected, so that's good. Okay, let me just see if this blows up again when I attach 10 volts. So to do that, I need to attach the 10 volt supply, turn that on, which is this one. Right, so if you can see, so here's my buck converter. The lights come on. The ammeter shows it's reading 10 amps. So if I attach this, okay, red to the top, that's good. Then the red wire goes to the top rail. So it dropped just a little bit, the voltage. Oh no, it's fine. So I plugged it in. Seems to work. So that's good. Alright, let me plug in the other power supply, provided 5 volts. So these power supplies, they've got a common ground. This is like the signal in. And let me just connect it and see what happens. So you can see that if that sort of starts smoking, we know we're in trouble. Keep an eye on the voltage as well. So that's taking a 5 volt signal one direction. If I turn it around, it's taking a 5 volt signal the other way. And that seems alright. I think I must have somehow shorted something out. I don't know quite what I did wrong. Alright, let's attach the load now. And we'll give it a go, see what happens. Well, that's blown up as well. Is that because it doesn't like what happens when the motor stalls? But that's what it is. There we go. So now if I plug it in, it blows up. It's actually caught fire. Right. Right. Well, I think I'm going to have to give up on this. So the answer is, this is interesting, the buck converter, it's now only providing, so this is obviously not happy. The buck converter's only providing 200 millivolts, but it is creeping up. I suspect what's happening is it's cooling down or whatever, being connected to the damaged thing's no good. Oh dear. Look at that, it got so hot, it's pulled the pins out. Oh no, right. Yeah. Alright, well I think maybe I'm providing the wrong signal for this thing, but it's not, it doesn't look good. It doesn't look good. I've blown up two of these things already. I think I'm going to have to go back to the drawing board a bit. Anyway, well, I've learned a few things. I've learned I can't use these. That's what I've learned. I'm going to come up with a better idea. Anyway, look, it was great to have those of you joined. It was great. Not been the most chatty evening, but I'm gonna stop stream now and go and have some proper supper. I'll see you again soon, I'm sure. All right, bye then.